All right, so today we're going to be discussing 11.1 and 11.2, where we're going to talk about transformations of a quadratic equation. So this is just day one of this lesson. We're going to do this in two parts. So make sure you have the day one note sheet from Google Classroom and something to write with. So what we're going to be doing today is identifying transformations of the parent function, x squared. So it's a quadratic equation. So our parent function, remember, we did this back when we did absolute value functions, where we had to do transformations of the parent function. So remember, the parent function is the most basic form of this function. Now this is a quadratic, so it's still going to be a parabola shape, a U shape. But the parent function always starts at the origin. Okay. Now when we start putting different numbers in the problem, like coefficients or adding and subtracting things, that's when this parent function starts to move about the coordinate plane. So it could move to the left, could move to the right. Okay. However it moves just depends on what numbers we put in the problem. So it's the same rules for when we did the absolute value functions, except now we just have a parabola instead of a V shape. But if we have a coefficient in front, that's your shrink or your stretch. So remember, if the A number was bigger, that stretch, we made the graph more narrow, we used to say. Okay, and the smaller the A value, if it was a fraction or a decimal, that made the graph more wide. Okay, and then remember, anytime you have a negative in front, that's going to flip your graph, okay, over the x-axis. So that's our reflection. So that's what we get from the A value. So this value here. Make that a little smaller. There we go. Okay. Anytime we have a value inside the absolute value like this, okay, remember, if it is a minus h, that moves the graph to the right. And anytime we have a plus on the inside, that moves the graph to the left. So this is the one we kind of had to go against our gut with. Negative was right, plus was left. And the last one is the up or down, our vertical shift. And that happens when we add or subtract a number on the end. So this one, we don't really have to think too much about it. If it's plus, it's going to move it up. And if it's minus, it's going to move the graph down. Okay? So those are all the transformations. So all we're focusing on today is naming what transformation is happening in our equation. So you should go pretty quick because there's not much to it. I'm going to leave this up here so we can see it for the first couple. But let's look at number one. We have an x squared and then a minus 3. So you see how that minus 3 is outside the squared term? That's this pink section here. That's a vertical transformation. So in this one, this graph, all it does, since it's a minus, it's going to go down by 3. And that's all. That's the only transformation because that's the only number in the problem. So let's look at number 2. What's number 2 going to do now if it's x squared and then plus 2? Hopefully you said to yourself, since it's a plus, that's going to shift the graph up. Goes up 2. So if you don't see any parentheses, then it's just your up or down shift. If it's outside of the squared term, up or down. But like 3 and 4, those ones are inside the squared term. So it's the x minus 2. That whole thing's getting squared. So that falls into our blue bracket here. There's that in blue. Our blue rules. Okay. So if it's a minus, minus says the graph moves to the right. So x minus 2 squared means this parabola is going to go to the right 2 units. Okay, so what would number 4 do if we have y equals x plus 3 squared? So plus 3 would move it which way? Hopefully you said that that's going to go left 3. Okay. All right, so let's move on. Let's get to some that involve a little bit more with them. So we have some coefficients in this next row. So that's all of our green things. So remember, if the A value is bigger than 1, it's going to be more narrow. If the A value is some kind of fraction or decimal, it's going to be more wide. And if there's a negative in front, it's going to flip the graph. It's going to be a reflection. So let's look at number 5. It looks like I have y equals a negative x squared. So all this graph does is flip. That's the only change to the parent function, is throwing a negative in front. So on number 6, if we have y equals a 2x squared, that makes the graph more narrow. So we would say this one is narrow, okay, by a factor of 2. So that just means your parabola, remember, is just going to be a lot more skinnier, okay, a little thin. So what would number 7 be if we have y equals 1/2 x squared? Hopefully you remember that a half makes the graph wider. So in this case, if we had a parabola that was wider by a half, it would still have its vertex. The graph would just go out a little further on each side. So that's the difference between something that's narrow and something that's wide. Okay. All right, let's put it all together in the last row. So maybe I'll make this full screen so we can see the rules on the top as well as do the problem. So we have 8, we have an x minus 1, and then a plus 5. So anytime there's a change to the parent function, the plain x squared function, there's a transformation here. So I see 2 changes. So that must mean I have 2 things happening to my graph. 8 pen. Okay, so a minus 1, that's going to move the graph minus, moves it to the right 1. And then the plus 5, that moves the graph up because it's a plus. So right 1, plus 5. And again, I'm just getting that from these rules from this table. Minus is right, plus is up. And again, it's all about the placement of the number. That's how you know what's happening. In the next one, we have a 1/4 in front. So anytime we have a fraction in front, I know this graph is going to be wide. So it's wider by a factor of a 1/4. And then I also see this minus 1 on the end. So a minus 1 outside the squared term is going to move it down. So it's going to go down 1 spot. Okay, so you try number 10. There's a lot going on in this problem. You have a negative, a 4 in front, a plus 3 on the inside of your parentheses, and then a plus 2 on the outside. So that's 1, 2, 3, 4 transformations. So list all 4 there for you. Okay, so let's start the negative. The negative is going to be a reflection. Okay, it's going to flip the graph. The 4 in front is going to make the graph more narrow, so skinnier. The plus 3 on the inside is going to move the graph to the left 3. And then the plus 2 on the outside moves the graph up 2. So that is how we list and name all of our transformations. So just make sure you have this box on the top. Save it somewhere so you can use it on your tests. But that is kind of your little cheat sheet. Got all the rules on there. Okay. So on the back side, we're just going to kind of put together what we did yesterday with this kind of new section. So converting something from vertex form, okay, if we had to do this in standard form, we'd have to do all that work that we used to do, like negative b over 2a, plug it in to get the vertex point, find the axis of symmetry, and all those things. So instead, what we can do is turn this into vertex form, and then we can just do the transformations like we did on the front. So remember, on these problems, what we're going to do is we're going to complete the square. So I'm going to put my x squared, my x terms together. And I'm going to leave myself space to complete the square. So I just kind of shove that 23 over. Remember, whatever I add on here, I have to subtract off in order to keep this an equivalent expression. Okay. Just move that over a little bit. So now we have to complete the square. And again, the whole point of completing the square is so I get this perfect square trinomial and turn that into something squared. So we take half of our b term, so half of 10, and then we square it. So half of 10 is 5. 5 squared is 25. So 25 gets added in on the front and subtracted off at the back. So that's going to give me in my parentheses x plus, so it's the same sign. And remember, it's always half the middle term. So x plus 5 here. And then we just finish this up by combining up these like terms at the end. 23 minus 25 is a negative 2. Just throw a y equals in front of that, and now we have an equation that we turn from standard form into vertex form. So now, quickly, I can just get those transformations. So maybe I'll get a different color here. So that plus 5 tells me that this graph is going to move to the left. So it's going to be left 5. And then that minus 2 says that this vertex point is going to move down 2. So in this case, I know where my vertex point is without doing all that work. All we have to do is a quick kind of rearrange the formula into vertex form. So I'm going to have you guys try number 2. So start by putting that into vertex form. So we have x squared minus 12x plus a blank plus 40 minus a blank. So if you need me to kind of help you get started and do the setup, I can do that. So this would be x squared minus 12x plus a blank. I'm going to move this stuff out of the way really quick. And then we just kind of shove that plus 40 down, and then whatever we add on, we're going to subtract it off to make sure we're keeping everything equal. This part should give you that nice perfect square that you'll rewrite using your squares. And then you'll just have to combine up like terms at the end. So finish this problem, get it into vertex form, and then tell me what are the transformations from that function. Okay, so here's what I have. Here's my equation in vertex form. So you should have gotten x minus 6 squared plus 4. So that makes your transformations right 6 and plus 4. So I'm going to pull out all the work here so you guys can see what I did. Here's all of my work. So again, the whole point of vertex form is so we can pick out how the graph transforms and how it moves on the coordinate plane without doing all that work that we used to do. Okay. So there's 2 more problems on here if you want to do them. I'm going to show you the answer for them in case you want it, but here's the answers for 3. And here's the answer for 4. And then there's the answers for the transformations. So give those 2 a try and see if you can get the right answer. But that is all we're doing in this lesson. So just knowing your transformations is kind of the key part of this lesson, how the graph shifts. When it moves up or down, when it moves left or right, when it becomes narrow, wide, or when it flips.